All right, it's time to get siggy with it. So with significant figures, there are a number of rules, and we're going to go through those really quickly, and then we're just going to go through and actually start to figure out how many sig figs there are in given values. So the first rule is all non-zero digits are significant, which means if you are given a numerical value and you see a 1 through a 9, you count that as a significant figure. The next thing would be is zeros are also significant most of the time. Okay, and we're going to see how zeros can kind of be a pain for figuring out sig figs. Terminal zeros that precede the decimal point in quantities greater than 1 are ambiguous. What does that actually mean? Well, it means if you have something like the value 200, this is only going to have one significant figure. Okay, if you have a value such as 34, you have two non-zero digits, so this has two sig figs. So there are two exceptions for values that are less than 1. It's whenever you have zeros that precede the decimal point, and then also whenever it's following the decimal point but preceding the first non-zero. So for example, what this is telling us is for a number like this that's smaller than 1, you don't start counting sig figs until you get to your first non-zero. So our first non-zero is this 8. So any of those zeros that come before it are not significant. Okay. So these next two zeros right here, they occur between two non-zeros. These are what are called captive zeros. So that means they are significant. So right now we know that this 8 is significant, these two zeros are significant, and then this 8 and 9 are significant. So the question is, what about these last two zeros? Are they significant or not? Well, if you have a 0 after a non-zero and after the decimal point, it means that it's significant because whoever was measuring or taking measurements for the data measured to this point, which means that these zeros are significant. So in this case, this value has 7 significant figures. All right. So really what you're going to do is to figure out whether a 0 is significant is you need to ask these two questions. The first one. So ask two questions to determine if 0 is significant. All right. First question, is 0 after the non-zero? Second question is the 0 after the decimal place? If you answer yes to both of the questions, then the 0 is significant. So let's relook at this example over here. All right, these first zeros, the very first 0, is it after a non-zero? Well, no. Is it after the decimal place? No. The next two zeros here in the 10th and 100th spot, is it after a non-zero? No. So these are not significant. All right, 8 we know is significant. The next two zeros, are they after a non-zero? Well, yes, they are. Are they after a decimal place? Yes, they are. So in that case, they are significant. The 8 significant, the 9 significant, and then these last two zeros. Is it after a non-zero? Yes. Is it after the decimal place? Yes, it is. So these are significant. So those are the types of questions that you should use as you're going through and determining sig figs. A few examples that are a little more challenging would be something like 20 versus 20. All right, so the first value up here, 20, only has one sig fig, because there's not a decimal place showing that it was measured to that ones place, the 0, okay? The 0 that's in the ones place. Whereas the 20 with the decimal point, this now tells you that the data was recorded to the nearest ones place, and it was a 0. So this one has 2 sig figs. If you have values such as 200, again, this would only have 1 sig fig without a decimal place, but if you add the decimal place, now it has 3 sig figs. If you made it 200.0, now this is telling us that it was measured to this nearest tenth, so it has 1, 2, 3, 4 significant figures. So really those are the examples that may be slightly more challenging. But we can also keep track of sig figs as we perform mathematical operations. So the easy mathematical operations are whenever you multiply and divide, and you just go with the number with the fewest sig figs. So one of the things you should note is that as we move along, we can multiply and divide regardless of the units. Okay? It may not give us a sensical answer, but a physically meaningful answer, that is, but you can still multiply and divide. What I would recommend doing is writing an answer down and then rounding it to the correct number of sig figs. So if you plug in 7.3 times 8.3149, you would get 60.69877. Well, how many sig figs should our answer have? Well, since this is multiplication and division, it should have the number of sig figs in the product that had the fewest, or the quotient that had the fewest number of sig figs. So the 7.3 has 2 sig figs, and the 8.3149 has 5 siggy figgies. So our answer should end up having 2. So since our answer should only have 2, we have 60, but we need to round it. So we'll look at that next digit, which is in the tenths spot. So we would round our answer to 61. So the correct answer here would be 61. All right, addition and subtraction is slightly more challenging, but if you write it out like this, you should be okay. One of the things that you should consider for addition and subtraction, and this is really important, this always tricks people up. For addition and subtraction, the values must have the same units. Or the operation cannot be performed. So you can't even add meters to kilometers. You would have to add kilometers to kilometers or meters to meters, but you cannot mix them. They have to have the exact same units. But the rules for sig figs for this is you go with the fewest numbers beyond the decimal place. So in this case, 15.02 is measured to the nearest hundredth. 9,986.0 is measured to the nearest tenth. And 3.518 is measured to the nearest thousandth. Okay? So we can add these because they all have the same units, but once we're done adding is we're going to have to actually cut this off to the nearest tenth. So whenever we add this, we should end up getting 10,004.538. But since we can only measure to the nearest tenth, we'll cut it off there. So we'll actually have to round this to 10,004.5 grams. And see, it's so easy to forget your units. I forgot to write my grams up here. So you're going to look to see where you're going to cut it off. The tricky part about addition and subtraction is you can actually gain or lose or have no change in sig figs. Whereas with with multiplication and division, it's always the value that had the fewest number of sig figs determines how many your answer should have. Addition and subtraction, you can gain, lose, or have no change in sig figs. But here, since the 9,986.0 grams was measured to the nearest tenth, that's where we are going to cut this off. We're going to round it to the nearest tenth. So what I would like you guys to do on your own is to try these practice problems and see what you get, and then we will go over these in class.